Good evening, everybody. Welcome to the final One Health seminar of One Health Week at Del Val. It's been a great list of seminars this week, and we've got an even greater one tonight with Bryan Huerta. He's a recent graduate in 2020 from Conservation and Wildlife Management and is currently working down at Mississippi State University Extension, working with sharks. And if any of you were around last year during One Health Week, you'll remember that he had a fabulous presentation, and he's going to give us even an update on the work that he's been doing now. Bryan, it is a real pleasure to have you with us, and it's all yours.
Hi guys, as Rich said, my name is Bryan Huerta. I'm an alumni from Delaware Valley University 2019, and I'm Conservation and Wildlife Management. All right, so here's a quick overview. So first I'm gonna discuss about my internship at Mississippi State University Marine Fisheries Ecology Lab. Then I'm gonna talk a little bit about shark diversity, and then the common sharks in the northern Gulf of Mexico. So a little bit about me. So as you guys can hear, I have an accent. I'm from Mexico City. So if you guys have any questions, please let me know. I came to the Marine Fisheries Lab in March 2020 as an intern, and officially my internship ends in October 2020. But now I'm like a extension program assistant. So I'm gonna be a little bit staying in the lab for a little while. So pretty much what the Marine Fisheries Ecology Lab is, they do a long-term bottom longline survey. Pretty much the area where we do the survey is Mississippi, Alabama, and we have some spots in Florida too. This provides information about distribution, abundance, and movement patterns of sharks and large fishes. This has been an ongoing study for 15 plus years. So I'm gonna share a video what is a bottom long line. I had some trouble putting it in the PowerPoint, so I'm just gonna exit a little bit here and just play this video.
A bottom long line is a type of fishing gear that samples large fishes living near the sea floor. We are the Mississippi State University Marine Fisheries Ecology Lab, and we conduct a long-term bottom long line monitoring program to learn about these large fishes of the north central Gulf of Mexico. Our bottom long line comprises 100 hooks baited with Atlantic mackerel. These hooks are called gangins and consist of a 12-foot piece of 700-pound test monofilament, beginning with a clip and ending in a large circle hook. To set the gear, we attach buoys to one end of a reel of 1,200-pound test monofilament, the main line, and release the buoys and main line into the water. Then we attach a heavy weight to the line to mark the beginning of the bottom long line. As our captains drive the boat forward, we clip gangins to the main line at 60-foot intervals. Once all the gangins are in the water, we attach another weight to mark the end of the bottom long line. To finish the set, we add buoys to the line and cut the line from the reel. After the long line soaks for 1 hour, it's time to haul. We pull the buoys onto the boat, reattach the long line to the main line, and start to retrieve the gear. All fishes that we can safely handle are brought on board for data collection and tagging. Data collection involves assessing the length, weight, sex, maturity, and overall health of the animal. We may also collect muscle tissue, otoliths, fin clips, and blood samples. Finally, we tag and release animals. The entire process from boarding a shark to releasing it takes less than 90 seconds. Sometimes we catch a shark that is too large to simply lift out of the water. When this happens, we all work together to either use a landing sling to lift the shark on board to tag it, or bring the shark close to the boat and tag it using a long pole. After we tag these large sharks, we quickly and safely release them from the long line. Our bottom long line monitoring program provides important data used to manage fisheries for these species and valuable information that will help us conserve populations of sharks and other fishes for generations to come.
All right, so this was a small video about what is a bottom long line. So before setting a line, I'm going to talk about preparing bait barrels. So a typical fieldwork day, like we wake up at 4 a.m. and then it's like, depending on the area that we're going to survey, it's like 3 hours, 2 hours away. So, and we try to do like in one day we do four spots. So we prepare the baits, and you always have to, so each barrel holds 50 gauges. As you guys can see, so here I have a gauge. In one end you have a tuna clip, and in the other end you have the fish hook. I don't know if you guys can see it. Yeah. So you always, when you're placing so you put the bait, you always have to make sure that the fish hook is facing down, because if you're facing upwards, like the person who's setting the line is gonna poke himself, and probably you're gonna get yelled like, why do you put it up? So you always have to be like, pay attention how you set the gauges. So here is like some pictures of myself like setting the bottom long line. So as you guys see in the video, first we attach a weight, then we do like the barrel, which as I said contains 50 gauges, and then you put another weight, and then you do a second barrel that also contains 50 gauges. And then after you are done with the gauge, after you're done setting the barrel, you cut the line, you touch a weight, and then you cut some buoys, and then you cut the line. So in that picture, you can see like how the tuna clips go attached to the main line. And after we set the line, so as you guys can see, as you guys saw in the video, we wait 1 hour to pick up the line. So during this hour, we take some abiotics. So we took this with these water variables with a YSI. So we take temperature, salinity, dissolved oxygen, and we take it at the surface water, at the mid water, and the bottom water. And it's very important to see like what variables are affecting the most. Well, like I mean, like different sharks, they have like different preference. Like bull sharks, sometimes they like low salinity, or the temperature too. And then turbidity, I'm not sure, guys, if you're familiar with the Secchi disc. So you like drop the Secchi disc, and then until you don't see it in the water, that's when you start picking it up, and then you start counting how many meters like you didn't see the Secchi disc. So that helped you to see like how turbid the water is, or like how clear it is. So racking is when you pick up the line. So here's Captain Tom, and that's me. And here in the right, there's two guys like waiting to process any fish. So it's very important that you pay attention, that always get like the gauges from the captain, because the captain, he's like moving the boat forward, he's like controlling the boat, and he's also getting the gauges. So you have to make sure you get the gauges, and you like put them in a manner like in a perfect order. If not, they're gonna get tangled, and it's gonna be very hard to, like when you set the line again, they're gonna get all messed up. And if we get a fish, the captain is going to pass them to these guys, and they are going to process them. And racking, I think is my least favorite thing, because I mean, I didn't get to, like, you don't get to process or handle sharks. So you're just like racking like all the hooks that they don't have any fish on them. So the common measurements we take there are 4 measurements we take. So total length, fork length, precado length, and stretch total length. So stretch total length is like folding the upper lobe, like the maximum length you can get. So we do the same for sharks and bony fishes. So specimens workup and data collection. So here we have a spaghetti tag. I have one right here. So pretty much any shark that we capture, we place an spaghetti cap. So it's like to see it's like capture and recapture like purposes. So like if a fisherman like capture a shark with this tag, it has a tag number, and there's a website, so they can call and say like, hey, I got a shark that has a tag, and then we give him like a gift card or something like that. So it's very important to see like how far that shark move, or like where the fisherman pick it up. In the right picture, that's me doing a small incision with this little knife and then applying a spaghetti tag. That's a baby tiger shark right here. And here my supervisor is holding the head. So other like samples we take during we're processing the sharks, we do fin clips, biopsy samples, like measurements, as I said, blood samples. And in some cases we take vertebra samples, or like even the stomachs, but we have to kill the sharks. So it really depends the species we get. For example, black tips, we have to kill them because we have to kill them because we are doing a study about black tips, about their diet and the age growth. So pretty much we take the like a vertebra and stomach. So in the left picture, you can see again the spaghetti tag. I'm reading the number to my supervisor or the person who is taking the data. And then after we take all like the weight and the sex, like all the data we have to collect, we release them back to the water. When the shark is too big, we use like pole tags. If you guys can see here, you can see the spaghetti tag attached to the pole tag. And the captain is moving the boat forward. So you have to get the right angle to attach the tag. You want to do it like horizontally. If you do it vertically, like down, you can damage the livers of the kidney of the sharks. So you have to get the right angle to put the tag. So sometimes like some species, they get crazy and they start like shaking. So you have to do it fast and like with enough pressure to do it. Also, sometimes we bring them on board, as you guys saw in the video. So that's me holding restraining the tail. Here's Marcus Raymond. Marcus Raymond is like the main boss. He's like the main guy who's running the lab. He's restraining the head, and there's a hose that provides water for the Scallop Hammerhead. Here we have Catherine, and she's taking like fin clip samples, other stuff. And I'm doing some measurements here. And in the right, we have a great hammerhead. You guys can see like, that was a huge shark. And you can see how many people took to restrain them. Again, I'm holding the tail, and some people are taking data and some samples. With hammerheads, you have to be very, very fast when you are like, when you have them on board, because they freak out and like they get like in shock, and if you're going too fast, probably they die. So you have to do like super quick, especially with hammerheads, scallop hammerheads or great hammerheads. Other sharks like tiger sharks, they are more resilient. You can even take your time and they are fine, but hammerheads are very fragile. So specimen workup with Bonnet fishes. It's the same. We do spaghetti tags sometimes, like the same thing. But also sometimes we take ocelots, which are pretty much ear bones. It's like, so you can do age growth studies. So they are composed of calcium carbonate and protein, which like, they form like rings. So it's pretty much when you got a tree, you know how you can see the rings and you kind of can estimate the age of a tree. So it's almost the same thing. It's the same with shark vertebra too. You can do that too with spines from sharks and fish too. Some sharks, they have also spines. I'm gonna talk more a little bit about that in a bit. So here is removing the ocelot, the ear bone that I was telling you guys. So we have to kill the fish in a humane way. We open the operculum first, and then with the chisels, there's like in the skull, there's like a capsule that covers the operculum. So you want to try to like poke the capsule to break it, but it has to be like just like pressure enough that you don't break the ocelot. Because if you break it, like you're killing a red snapper for nothing now. So once you break like this little capsule, you remove the ocelot. And so here it is. And then when you see it, like when you like prepare it for like in a microscope, you guys can see the rings here. So you can estimate the age of how old this fish was. And some other stuff I got to do is during this lab is articulated shark skeleton. Sometimes like we get depredation. So like sometimes when we pick up the line, there was just like the shark head. So other shark ate the shark that was in the hook. So sometimes I like take advantage of that and like clean the specimen, the skulls. So here we have a cephalofoil that I clean of a Scallop Hammerhead spirnaliwini. Here we have an Atlantic sharp nose, Prisopranidon terranovae. And we have here a angel shark, Squatina. I think it's Squatina deville. No, Squatina. I forgot the species, that one. Dumerelli. So now I'm going to talk a little bit about shark diversity. There are more than 500 species of sharks. I think many times we see like the tiger shark, gray whites, whale sharks. Like the most charismatic species all scientists seems to care, but there are more than 500 species. And there are many species that actually really need like a lot of help. But as they are not charismatic as other species, it's very hard to also get funding. So there are 9 orders. So the Hexanchiform, this is your most primitive order. That's where you have the frilled sharks and the cow sharks. So the main distinguishing factor between this order is that they have like 6 gills or 7 gill slits. On other sharks, most of all sharks have 5 gills. Then you have the Echinorhiniforms, that's the bramble sharks. There's only 2 species. This order used to be a family in the Squalliforms, but some scientists found out that actually they are very different, that they can be considered now their own order. The Squalliform is the dogfish sharks. There is 130 plus species. Then you have your Pristioporiforms, saw sharks. Don't confuse with sawfishes. Saw sharks are actually sharks, while sawfishes are batoids, rays. So actually here in the right, we have a rostrum from, this is a rostrum I have from a saw shark that came from Philippines. So saw sharks, they shed constantly the tooth spines, like they change it. Like they shed it, while sawfish, they never do it. So if they lose one, they are not going to grow it back. Then you have your squatiforms, angel sharks, 20 plus species, heterodontiforms, bullhead sharks. There's 9 species, lamniforms. Those are the mackerel sharks, 15 species. That's where you have your mako sharks, sand tigers, gray whites, basking shark, goblin shark. So like that order actually received a lot of attention, but there is only 15 species. Then you have your orectolobiforms, carpet sharks. That's where you have your nurse sharks or whale sharks, gobegons, and other species. And then you have your Cacariniforms, 291 plus species. Those are the ground sharks. That's where tiger sharks are, blue sharks, bull sharks. A very diverse order, and actually many shark fisheries. That's where mussel is very important in the shark. This order is very important in shark fisheries. Also, like 1 year ago, so since I'm from Mexico City, there is a huge fish market, and I was just like surveying. I went every day to the fish market to see what species I could see, and many of them they were from that order, Carcariniforms. So I'm sure you guys are familiar with the Iucn Red List, but I'm just gonna mention it because I'm gonna talk a little bit more about it. So the Red List is the most comprehensive information source on the global conservation status of an animal, fungi and plant species. It's a critical indicator of the world's biodiversity, provides information about range, population size, habitat and ecology, threats and conservation actions that will help necessary conservation decisions. The status are revised every 5 to 10 years. So here we see the conservation status of sharks. So we can see, and that's from 2013. So, I mean, many things have changed already. Actually, there is a book from Dave Everett coming next year, which I'm looking forward to have it, which probably is going to be updated. Many things have changed probably. And also many many Red List assessments are going to be updated soon. But from 2013, there are 11 species that are critically endangered, 14 species endangered, 69 species near threatened, 49 species vulnerable, 120 species least concern, and 214 species data deficient, and 24 not evaluated. So here is a huge amount of shark species that we don't really know how their population are doing. We don't know like their biology, their life history, or their conservation status. So here is more like a map. So 52% like what we know about sharks, and 48% remain unknown. That's so many species of sharks that we don't really know that much about them. So shark diversity in the Gulf of Mexico. There are over 67 species of sharks found in the Gulf of Mexico. I mean, probably there are way more, but some deep water species, there is like a lot of uncertainty. For example, like in 2005, we didn't really know that Greenland sharks can be found in Mexico. So in 2005, there was a record of a Greenland shark found in the Gulf of Mexico. So many deep water shark species, we don't really know actually like the exactly distribution map. And here the Marine Fisheries Lab have registered 19 shark species in the Northern Gulf of Mexico. So what are the most common sharks in the Northern Gulf of Mexico? This is according to the lab where I'm working now. So here the most common shark is the Atlantic sharpnose, which is that one. Then we see the black-nosed shark, Cacarrinus acronatus, then the blacktip, sandbar shark, bull shark, spinner shark, tigers, mudhound shark, scallop hammerhead, and fine tooth. I'm gonna talk more a little bit about each shark more, so you guys can know the main distinguishing factors of them. So shark anatomy. So this diagram is like a Frankenstein shark. It has like all the traits you can see in a shark. So you won't see any shark, and you won't see any shark species that has all these traits in this diagram. But it's like very easy, like where you have to look for. So like you have your nostrils, snout, labial furrows, gill openings, or are called also gill slits. Your first dorsal fin, spines. Some sharks have spines, some don't. Your second dorsal fin, precaudal pit, pectoral fin, pelvic fin, and anal fin. And here you have the caudal keel. This is a very important characteristic in lamniforms. So gray whites, mecos, they have a caudal keel. So I'm gonna talk about the Atlantic sharp-nosed shark, Rhizoprenion terranovae. As I said, this is the most common shark found here in the northern Gulf of Mexico. And actually, when I was in Mexico City too, I saw, like every day, I saw Rhizoprenion terranovae. So that's probably, it's kind of safe. It's safe to say that probably is the most abundant shark in the whole Gulf of Mexico. So the average size is 3.6. Well, the maximum size. The red list is least concern. So in number 1, the error responded, they have like elongated labial furrows. Also, number 2, they have the pectoral fins, they have white margins. Some sharp-nosed sharks, they have white spots. Juveniles, they don't tend to have white spots. It's pretty much with adults. And then if you see the second dorsal fin and the anal fin, the second dorsal fin is more posterior. So posterior means towards the tail and anterior is towards the head than the anal fin. Very unique tooth morphology. Sometimes just looking at the teeth, you can know like what species are. So many shark species, they have very unique tooth morphology. So it's very important to also analyze the jaw structure and the tooth shape. Here we have the Caribbean sharp-nosed shark, Rhizoprenion porosus. So it looks exactly the same as the Rhizoprenion terranovae. As far as I know, there's no way to tell them apart unless you count the number of vertebrae. So the Rhizoprenion porosus, they have more vertebrae than Rhizoprenion terranovae. I'm here in the Mississippi aquarium. They have like an X-ray machine. So sometimes I just bring them sharks and they just take an X-ray picture. And this allowed me to count the number of vertebrae easily because it's super fast. Instead of like when I clean a shark, it takes me forever to like clean it and like count the number of vertebrae. With an X-ray, it's super easy. The problem with this is that Rhizoprenion terranovae, the Atlantic sharp-nosed shark, is the most abundant and there's no restrictions. Like you can fish as many as you want. While the Rhizoprenion porosus is a prohibited species. So I know some scientists are trying to maybe to look more at like taxonomically, like if there any characteristic that may help sorry guys, fishermen to distinguish these two species. As is a prohibited species, but as now, they both look the same. And it was believed that the Caribbean sharp-nosed shark, it was only found in the Caribbean, but not. I was reading a paper that they collect some sharp-nosed samples from the Gulf of Mexico, and some fin clips, and they result to be Rhizoprenion porosus, the Caribbean sharp-nosed, and not the Atlantic sharp-nosed. So you might be collecting a prohibited species without even know it. Don't know it. Here we have the black-nosed shark, Carrinus acronatus. So number 1, as its common name says, it has like a dark pigmentation on its snout. And also in number 2, they also has dark pigmentation in the second dorsal fin. The size is 4.5 meters. The size is 4.5 meters, maximum size. The red list is listed as near threatened. Here we have the black-tip shark, Carrinus limbatus. I have to say, I did these all illustrations based on live specimens. So sometimes when we get a shark, I like take pictures and I use them as reference. Because when you see like a dead shark, they lose the coloration fades so quickly. So you want to have pictures of a fresh specimen as quickly, like as much as you can. The size is 8.3 feet. That's the maximum size, and the red list is near threatened. Here, the first dorsal origin from the first dorsal fin meets right the pectoral fin. And in number 2, they don't have black pigmentation in the anal fin. But this is only in specimens found in the Gulf of Mexico or in the Atlantic. Specimens from the Pacific, they do have black pigmentation on the anal fin. And this might be they might fall into a species complex. So that means that probably there are more species that they look like exactly the same, but we don't really know yet. Also, Pacific specimens that are way bigger than the ones found in the Gulf of Mexico or the Atlantic. And here is like many field guys points out that, oh, if it doesn't have black pigmentation here, it's a black tip. Because black tip and spinner shark, the one we're gonna see in the next slide, most of the time people confuse them, these two species. So here's the spinner. So spinner, they do have black pigmentation in the anal fin, while black tips don't. But Pacific specimens, they do. So again, here we have the spinner shark, Carrinus brevipina. They have a very pointy snout. The second, number 2, the dorsal fin is like way behind. It's more posterior than the pectoral fins. And number 3 is pointed about the black pigmentation on the anal fin, as I was telling you. And again, also like specimens from the Gulf of Mexico and the Indo-Pacific or Pacific Ocean are very different. I know that the Indo-Pacific specimens are way bigger, but the tooth size are way smaller than the ones from the Gulf of Mexico. And I think some authors have suggested that there are different subspecies, but no one, as far as I know, no one has done a work do research about it. Then here we have the Dusky shark, Carrinus obscurus. The size is 13.1 maximum size. The red list is endangered. These are prohibited species. Again, look at the fin positions. The dorsal fin is just right below the pectoral fins, the fin origin. And they have an interdorsal ridge. So in that picture, we can see the interdorsal ridge. So the interdorsal ridge goes along from the first dorsal fin to the second dorsal fin. And the second dorsal fin is almost the same height as the anal fin. This is the biggest Carrinus. This is the biggest shark from the genus Carrinus. The jaw morphology is very similar from the ones from bull sharks, but they have more teeth than bull sharks, Carrinus leucas. Here is a silky shark, Carrinus falciformis. They have a very dark coloration when you see them. The contrast is very noticeable in number 1. Like in number 2 is pointed about how far the first dorsal fin is. And they have a very small dorsal fin to the first dorsal fin. Also, there are ridgeback species. They have an interdorsal line that goes from the first dorsal to the second dorsal fin. And number 4 is pointed, they have very long free rear tips. So this is called like free rear tip. The size, the maximum size is 10.8. The red list is vulnerable. That's a cited species, that means it's appendix to. So cited species, any cited species tends to be protected from international trade. So if you are sending like any product from a silky shark or any cited protected species, if it's appendix 2, or any appendix, you need to, and Rich, you can call me out if I'm wrong, but like the country where you are, like from the country of origin, you have to get a CITES permit, and also the country you are exporting the fins.
That's correct.
But many times this is not reinforced at all. Sometimes I go like to souvenir stores and where they sell like shark jaws. Many shark jaws are imported from the Indo-Pacific, from Taiwan or the Philippines, and I've seen so many CITES include the species. But it's not reinforced. And maybe it's very hard to from any other people to tell them apart. But I've seen many like Scallop Hammerhead, Silky jaws, and even treasures too, which all are cited species. Here we have the sandbar shark, Cacarrinus plombeus. They have a huge first dorsal fin. That's like the main distinguishing factor. They are also ridgeback species, and the first dorsal origin meets the pectoral fins. The maximum size is 8.2. The red list is vulnerable and is also a prohibited species. I put like average because sometimes you don't really know how they record the maximum size. Sometimes they tend to overestimate, so it could be more, it could be less, but it is about 8 feet. Here we have the Carrinus leucas bull shark. And bull sharks, they are just chunky. They are bulky. They have a blunt snout, so that's where number 1 is pointing. Number 2, they have a very tiny small eye. And number 3, the second dorsal fin is more anterior than the anal fin. The size is 11.1 feet. That's the maximum, as I said. And the red list has it near threatened. Bull shark has very similar to morphology like Dusky sharks, but they have less teeth. The tooth formula is less teeth than the Dusky sharks. Here we have the fine-toothed shark, Carrinus Isoton. That shark is a beautiful shark. When you see them alive, they have a very beautiful bluish coloration. Number 1 is pointing to they have very pointy snout. The eye is bluish, and they have very big gill slits, almost like a mako or gray white. That reminds me like a mako or a gray white. They have very elongated gill slits. And number 3 is the bluish coloration. The maximum size is 6.2, and the red list near threatened. The tooth morphology is very similar from the ones from Carrinus brevipina, the spinner shark, but they don't have any serrations at all, while spinner shark they do. And here is the tiger shark, one of the very charismatic species. I did this illustration based on a juvenile specimen that we got here in the Gulf of Mexico. So when there are pups, they have they are purplish, and the stripes are super noticeable. They also have ridgeback. They have a ridgeback, but that species you can keep it. And they have a blunt snout. The size is 18 feet, and red list near threatened. They have also very unique tooth morphology, especially designed to they can even crunch toral shells and carapace. Here we have the short-fin mako, Isidus oxyrhynchus. There are 2 species of makos you can find in the Gulf of Mexico, but Isirus pacus, the long-fin mecco, and the short-fin mecco, Isirus oxyrhynchus. The short-fin mecco is the most common shark. Actually, during my time here, I haven't seen a long-fin mecco. I got to see so many at the fish market though, and they have very elongated gill slits, kind of like the fine-tooth shark I was telling you. Very small second dorsal and anal fins, and they have the cattle gill, and they have a homocercal tail. So homocercal is almost like the upper lobe is almost the same size as like the lower lobe. So if you that's a heterocercal. So like the upper lobe that's a heterocercal tail. So the upper lobe is way longer than the lower lobe. And here we have the family Spirnidae. That's the bonnet head shark. And if you're in the Gulf of Mexico or in the Atlantic, and if you encounter a shark with this head looking, there is no way you can you're not misidentified. Unless in the Pacific you have the Spirna corona, which looks very similar from the bonnet head. They tend to get freckles. And also this shark, they grow super fast. They reach maturity in 5-6 years. The tooth morphology also is very unique. So posterior teeth, they're more molariform, more adapted to crunch stuff. They love blue crabs, so they're adapted to crunch the blue crab shells. And the anterior teeth are more cuspidate, so more for grasping, grabbing the prey. The size is 4.9, and least concern. And as I said, it's a very, if you want to eat shark, that's probably a sustainable way. Bonnet heads are sustainable. It's a good option. Then we have the Scallop Hammerhead, Spirnally Winnie. So as I said, the hammerhead shape is called cephalofoil. And number one is pointed to, they have the cephalofoil, they have very pointy. And number two is indented. The maximum size is 12 feet, red list, critical in danger, and side is appendix 2. So if we see a great hammerhead, you guys can see that the cephalofoil is not pointed, but is indented as the Scallop Hammerhead. And also you have the smooth hammerhead, Spirna cigaena. I think there are no records in the Gulf of Mexico, but the cephalofoil looks very similar from the one of the Spirnally Winnie Scallop Hammerhead, but it's not indented. But it has the same pointy characteristics. So the great hammerhead is average 20 feet maximum size. The red list, critical in danger, and side is appendix 2, as the same as Scallop Hammerhead. They have very unique tooth morphology too. The lower teeth are way bigger than the upper teeth. And this is very rare. This is a unique characteristic. I believe that's the only shark from the order Carrinus that has this trait. Also, is vice versa. Upper teeth, they tend to be way bigger than the lower teeth, and great hammerhead is otherwise. And upper teeth and lower teeth are serrated, they have strong serrations, while Scallop Hammerhead, they might have finely serrations, but that's it. And then I'm gonna talk a little bit deep water shark species. I'm just mentioning just a few species because I haven't got the opportunity to see many deep water shark species because we don't go fishing that deep. I think the deepest we have gone is 90 meters. So here we have a Goldberg shark. So sharp-nosed 7-gill Heptranchia sperlo. As its common name says, they have 7 gill slits on each side, and they only have one dorsal fin. If you guys like other sharks, they have like 2 dorsal fins. And if you guys remember that this is the Hexanchiforms belong to the order Hexanchiforms, which is one of the most primitive sharks. And the red list is classed as near threatened and is a prohibited species here in the US. And here we have the Goldberg Shark, Centrophorus. I put just Centrophorus SP because there are so many doubts taxonomically about this genus. But as far as I'm concerned, Centrophorus ullaru is the most common shark found in the Gulf of Mexico. You can also find Centrophorus granulosus. And I have been told that when you go fishing about 300 meters, you can get many Centrophorus ullaru. It's like the most common shark. It's like the sharp nose of the deep water sharks. They have dorsal spines, and they're missing an anal fin. They don't have anal fin, they only have the pelvic fin. And they have very unique also tooth morphology. So, any questions?
So if you have any questions, down at the bottom of the screen is Q&A. You can type them in down there, and then I will read them to Bryan so he can answer your questions. Bryan, I've got a question for you while we're waiting to see if others will come up with it. Between the scalloped and the great hammerheads, both of them are listed as critical, but yet they are under CITES only Appendix 2. You have
Yes.
any idea why they're not Appendix 1?
I'm not really sure. As far as I'm concerned, there are also different populations of at least I know of Scallop Hammerhead. There are at least 4 populations. So again, it's like if these populations should be managed as a whole or separate.
Okay, that makes some sense.
I mean, so far it's Appendix 2, but I know that the Red List is gonna revise many shark species, so I'm very curious, like, if the status is still gonna be Appendix 2. I mean, here in the US, like you can fish hammerheads. So I think it really depends on how the local populations are doing. I believe you're allowed to keep 1 hammerhead for boat, for vessel, like if it's recreational, like here in the federal waters.
And is that for a season?
I think so.
Okay. Huh. Yeah, that seems interesting that something that's listed as being critical, I would think would be totally prohibited for taking at all, at least in the United States. That's interesting.
Well, like sometimes like some US regulations, sometimes they don't match with like Red List.
Right.
Or like CITES. So it's like, it's kind of controversial.
Yeah, yeah. Well, I imagine when you're talking about ocean species that there's a lot of opinions out there and maybe not much data. Like you said, almost half of the species are dated to fishing. So that's pretty disturbing, actually.
Yes.
We've got a couple of questions for you. So one is from Anonymous, and it's, what are the illustrations for?
So right now I'm working with the Mississippi Aquarium too to make a booklet to help identify like sharks.
And another question from Anonymous is, do you ever catch rays on the boat with MSU?
Yeah, sometimes we get southern stingrays or blunt nose on electric rays. And actually, if you guys want, I have some wet specimens or preserved specimens I can show you to you, like from sharks. So if you want to see any of those, just let me know what species. We have Sharpness, we have Meko, we have a tiger, we have a fine tooth, black nose, and I think we have an electric ray and a Atlantic stingray. So if you guys want to see any specimens, just let me know.
So on the long lines that you're using, how long are you leaving those set? I think you said that, but I think I missed it.
It's 1 hour.
1 hour, yeah. Huh.
Yeah, so we set the line, we wait 1 hour, and then we pick it up.
And what's your average catch rate for 100 hooks?
So it really depends on the water, the abiotics, the water variable. So if dissolved oxygen is very low, probably we're not gonna catch anything. And also it really depends on the spot, the area where we are going fishing. So like some species, they prefer certain depth. Like for example, smooth hounds, they like to be like the 90 meters, like 70 meters. While sharp nose, they're more like coastal. So it really depends on the area and the variables too.
We got another question. Can you show the black tip or black nose shark specimens? That's
Yes.
from Mary. Hi,
you
Mary.
You guys give me, hold on, I just have to wear some gloves because they're placed on isopropyl. So black nose, right?
Yeah, black tip or black nose.
Can you guys see it?
You might want to shut down your presentation so that they can see it full screen.
Let me just.
Oh, I should have said that beforehand, huh?
Yeah.
You could just hit stop share. There you go.
Can you see now? Can you see
Yep.
me now?
Yep, we can see you now.
So here is a black nose. As I said, it has like black pigmentation in the second dorsal fin. And also you can see like the black pigmentation in the snout. I'm sure you guys can see.
Mm-hmm. That was
So
like
that was-
3D.
Yeah, that was a female. Any other specimens you would like to see?
Oh,
We have a tiger to a Meko.
Oh, that'd be, yeah. Tiger would be nice.
Okay.
Beautiful.
Let me move my camera a little bit closer.
Well, we have another question for you too. What has been the biggest surprise on the boat?
Well, a Dusky shark, they're not, I think the lab has only seen 2. So that was very exciting to see one. It seems they are not very, I mean, you can see them like in the Gulf of Mexico, but they're not as common as other sharks. But also we have got like huge tigers. The tiger sharks are a mess. They like wrap up in like with the line. So sometimes it's very hard to like untangle them and release them back, especially the big ones. Here's a juvenile tiger, mostly like a baby tiger shark. It has an interdorsal ridge. I mean, and these are like wet specimens, so like when they lose the coloration super fast. A blunt snout.
Cool. So before the presentation started, Bryan and I were talking about taxonomy, and I think it's interesting that we both agree that it's kind of important to be able to identify what it is that you've got. And that especially if you're wanting to engage in conservation, that if you don't know what it is you're looking at or what you're trying to protect, that kind of leaves you at a little bit of a loss. And unfortunately, there's a real lack of taxonomists, I guess, within the shark research world, is what Bryan was saying to me. So.
Yeah, many shark researchers, they tend to care more about ecology. There are a few that actually like pay attention to taxonomy. I was telling Rach that actually today I just read a paper that about the publication says new records of big I6 gill in the Mediterranean. And I saw the pictures, and it was actually a Sharpness. It was a Sharpness 7 gill shark. So I was like, how that happened? Like, when you do a publication, they have to go peer review and like have to go to like several steps in order to be published. But it seems no one noticed that the pictures that they are showing is actually a Sharpness 7 gill.
Yeah, and how can you talk about ecology of a species if you don't even know what species you're looking at?
Exactly, yeah, it's super important. So here we have a short fin mako. You guys can see like the huge gill slits. I don't know, it's clear enough.
Yeah, I can see it. Yeah.
And the cattle gill.
That's beautiful.
And as I said, we have a homocircle tail. Very pointy snout. And the pectoral fins, they're like short. That's why it's called like short fin mako. While the long fin mako, they have very elongated pectoral fins.
So Bryan, could you tell us a little bit about how you got your internship, and is this something that they will be continuing in the future?
So, as I mentioned before, I'm naturally interested about shark taxonomy. So when I'm in Mexico, I tend to visit the second largest fish market in the world. So this like gave me the opportunity to like get my hands on many shark species. So during my internship, I saw sharks. I saw like many sharks, but in the fish market back in Mexico, I have many like huge amount of sharks available that I can just talk with the fishermen, like collect samples and just get my hands on. So when I applied to this internship, I mentioned about the fish market to Marcus. Marcus Raymond is the researcher, the main guy who run the lab. And he totally loved the fish market. And I think that was like the main reason that made me stand from other, like my other people. He even has told me to me that I'm an outlier. Like many people that said, "Oh, I love sharks," but they only care about like charismatic sharks or just about like tracking ecology. But I'm his first intern that he's really into taxonomy. Many people, as I said, many people don't really, they are not interested.
That's cool. That's cool stuff. We're just about out of time. But Bryan, this has been a real pleasure to see you again, even if it is virtually. And I hope that everybody has enjoyed your presentation as much as I have, and your incredible illustrations and photography. Beautiful stuff. I know we're going to hear lots more about your work in the future. I wish you only the best. And I hope that people have learned a little bit about, yeah, you got to put yourself out there, demonstrate your passion, and you're going to go places. And I'm proud that you came to Del Val, Bryan.
Thank you so much, Reg. I think it's very important, like to like to be like persistent. Like, okay, you want to study sharks? Like, show it, you know?
Yep. Yeah.
And I think that's like the main thing that helped me to compete with other like interns in the past. So if you guys have any questions or more like anything you guys would like to talk about it, feel free to reach. Maybe Reg, I can give you my email, and if anyone have like more questions about this internship or maybe like opportunities to be an intern here, I will be happy to.
All right.
Help you.
I'll pass your email address on to anyone who's interested. And thank you all for attending tonight. Thank you, Bryan, for being post-hurricane in the lab and showing us some cool stuff. And good night to you all. Have a great night. See you later, Bryan.
See you, Reg. Thank you so much for having me.
Take care.
You too. It was nice to see you.
It's great to see you too. Bye-bye.
All right.